Good afternoon, everyone, and welcome. I'd like to welcome everyone. We're the Rotary Club of Gainesville. Today is May 27th, and welcome the day after Memorial Day. At this time, guests and visiting Rotarians, if you're joining us on Zoom, please identify yourselves in the chat. And if you're watching on YouTube, please register your participation by sending an email to info@rotarygainesville.org. And our song and pledge today are brought to us by Tom Collette.
Thanks, everybody, for that wonderful welcome. Since the Gator softball team is off to the College World Series and the Gator baseball team is hosting a regional this weekend, let's sing Take Me Out to the Ball Game. Are you ready? Take me out to the ball game. Take me out to the crowd. Buy me some peanuts and Cracker Jack. I don't care if I ever get back, 'cause it's root for the Gators. If they don't win, it's a shame, for it's 1, 2, 3 strikes, you're out at the old ball game. Go Gators! Now please remain standing and join me in the pledge to our flag. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you, Tom. Lori Bedell.
Well, I do want you to know that I do have firsthand information that baseball will be the sport that is played in heaven. So you can just kind of count on that. So it's kind of a joke, you know, you can kind of lighten up there. So but here we go. Let's pray together. Thank you for this welcome break that we have had to celebrate a day of recognition with such importance as Memorial Day, to remember all who have made the ultimate sacrifice and service for our country. We are so blessed in our nation in so many ways, and for that we are so grateful. And now we launch into the summer months with a sense of transition from busy school schedules, especially for our younger students, to summer vacations and special opportunities for relaxation, fun, and healthy personal growth. Refresh our spirits over the months of summer. Bless our efforts as a Rotary Club as we anticipate in the next few weeks our transition of leadership for the new Rotary year. And now we anticipate the enjoyment of our program today. Encourage the spirit of those participating in such a way that this becomes another building block leading to their future blessing and success in the years before them. We offer this prayer humbly before you. Amen.
Thank you very much, Lori. You may be seated unless you brought a guest or visiting Rotarians. If you would remain standing, and we'll bring around the mic to you.
So I'd like to welcome Noah Wilburn. He is with I Am Creative. He is the CEO. He is a young gentleman that I'm trying to get to be part of our Rotary, and he does amazing video, podcast, and digital marketing. Noah Wilburn.
Welcome, Noah.
Hello, Rotarians. My name is Craig Carter, and today I want to introduce Ray Holt. He is the owner of C-Bar Ranch out in La Crosse. If you haven't been there, it's an amazing opportunity. It's a wedding venue and celebration area. And also, I prepaid the $125 to David. Ray is running for Alachua County School Board District 3, so please get to know him and know all your candidates before you vote.
Welcome, Ray.
I'm Richard Allen, and my guest today is Lee Purvis. Lee's from Shreveport, Louisiana. Actually came here originally to graduate school, has now returned to Gainesville and is thinking about Rotary, and he works with kids in the education system, counseling.
Welcome.
Good afternoon, fellow Rotarians. I have my son Cecil Gracie with me today. Cecil is a rising freshman now at over at Oak Hall and out of school, kicking off the summer. He's here with me today to see to get educated on some neat science projects. So please welcome Cecil.
Welcome, Cecil. All right. All right, so now we're to announcements. Bill Stanowitz, I think, who wanted to be called Pizza Bill. Come on up. That's what he said. Come on up.
I could do. I had to show you guys the woo clap someday. Okay, so I'm here to just offer a little special. Can you hear me all right? Recognition. And I think Wes's grandson says if you're always being recognized, it isn't service. But he provided me, and he's been working a lot of hours on trying to fix my computer. But that's not really why I'm here. Is that I'm trying out this thing called random recognition. And if you guys remember, we had this thing in 2020, February somewhere, COVID thing, and it kind of messed things up. And there was a transition between Chad and Matthews. And I don't know who presented the group, whether it was Chad or Matthew, but we had a speaking group and there was 4 financial planners that gave us a little discussion. And if some of you are aware, I like to send out little notes, and I just got some positive feedback from my little note today. And so I sent out 4 of these, and I don't remember any of the other 3, but the one guy who called me back, and his name was David Gracie. And so I got a little random recognition here. Come on up here. I didn't know your son was coming, but David was one of the 4 financial planners that did a presentation on managing your money during COVID. And I don't remember what he said or any of the other 4 or 3, but he did. He was the only guy who called me back. And so I know he'll get back with you if you need to. Thank you, David.
Thank you, Bill.
All right, here you go.
Thank you, Bill. That's very cool of you to do. Bill, you do a lot for our club, and thanks for I'm glad that meant something to you, that you took time to write me a note, and I just thought that was the natural thing to do, to thank you for that. Melanie, Shelley, okay.
Okay, I'm going to turn the program this time over to President David.
Okay, everybody, welcome. It's great to see everyone today, and I want to especially, well, before I do that, I thank you, Melanie, for that intro and for keeping me on task, and thanks, Tom, for stepping up today to help Wesley and the crew get set up. And where's Lori? Lori, thank you for that prayer. That was a meaningful prayer. You always give us a meaningful prayer, but thank you. I want to especially welcome our science project presenters today. We've got a really neat program, and we've got, not sure what the number wound up being. I think we've got like 4 or 5 of you guys, but I got to chat briefly with each of you. Audrey and Abith, Maggie and Kevin and Shiven. So John's going to formally introduce each of you guys momentarily, but welcome. And again, I tried to express this earlier, but this is a very casual crowd. You don't need to be nervous up here. We want to be educated by you guys. So you know a lot more than we do about your projects. We're looking forward to hearing from you. I'm going to be brief because we've got a lot of projects to get to, but I just want to say that I hope everyone had a wonderful, relaxing Memorial Day, kind of a kickoff to the summer. I certainly did. I got to spend some time with my family. I hope each of you were able to do that also. But we went over to Crescent Beach, and we did a little surfing, Cecil and I, and we played a little golf, Cecil and I and his mother. And we actually got a rain out day on Friday. So we went to the movie theater and caught Top Gun Maverick. Awesome movie, especially if you were in the high school era like I was when the original one came out. It was a great movie. So anyway, I hope everybody had a relaxing Memorial Day weekend, and I'm glad to see each of you back here today. And folks, we've got a great program, and I just want to mention that John Gregory is not only the chair of our science projects each year, which takes a good bit of planning to talk to each of the presenters and their teachers, their parents, to make sure we've got everyone ready. But John is also our club historian. And he's also, we all know, our poet laureate. John's been a member of this club since 1982. And he's one of those guys that, you know, kind of flies under the radar, but does a lot of work in the back room. So let's please give John a nice Rotary welcome as we begin our program.
I know you're all expecting a poem from me, right? Well, I happen to have one. These kids are really the force as their grades climbed up in their course. I used to think, the award they'd think, National Merit was a movie about a horse. Okay. Our first presenter is by the way, you need to understand, these kids are middle school kids. They're not high school kids. These are middle school kids. So hopefully you'll understand what they're saying. Because let's start with Miss Hertel from Westwood Middle School. And where is she? Come on. Yay, come on. You're okay. Over here. Up here. Yeah, sure.
Yeah. So, hi, I'm Audrey Hertel, and this is my project. It's about girder bridges and flooding. How does the speed of floodwaters affect how long girder bridges can stand before breaking? A little background for this project is that girder bridges make up more than half of all bridges in the US, but they can be damaged by flooding in a few ways. This project looks at how flooding damages the girders that support the bridge's superstructure. This is important because of climate change. Climate change increases the strength and frequency of extreme weather events like hurricanes, and those increase the potential for flooding. When flooding occurs in populated areas, it affects infrastructure. Bridges can be washed away, making it harder for people to evacuate, get emergency services, and rebuild. For every science fair project, we need to have at least 3 references. So these are mine. To remind you of the question, it's how does the speed of floodwaters affect how long girder bridges can stand before breaking? My hypothesis is that if I send water down a bridge, a channel to represent flooding, then when water is fastest, the bridge will break because it was only meant to have so much pressure on it. The materials I used, well, First, I used Connects, which is on the left. Connects is rods that can be connected together by the ends. When I used those and tested them, it was too flimsy and they just fell over. Next, I tried Legos. If you don't know what those are, they're plastic bricks that you can connect together. Those wouldn't break even if I blasted them with a jet of water. Then third, I tried Jenga blocks, which are wooden blocks that are used for a game. You pile them on top of each other and take turns until it falls over, until the tower falls over. I found those to work best because only some of them fell over at different speeds of water. So the materials I used were 14 of these Jenga blocks, 1 bathtub, water, and a 5-gallon bucket from Home Depot. My procedure was I built the Jenga bridge in the tub. It was 18 inches away from the 5-gallon bucket. The bucket was at the back of the tub. For each trial, I filled the 5-gallon bucket halfway with 17.2 pounds of water. Then I poured the water from the bucket while counting down for 1, 3, 5, and 7 seconds. The water went down the middle of the tub and I stopped when I reached 0. There were no risks or safety issues with this experiment except maybe falling into the tub. My trial results were for 1 second when the water was fastest, 0 out of 14 of the blocks were left standing for all 5 trials. For 3 seconds, for trial 1, 8 out of 14 were left standing. Then for the next 2, 4 out of 14. Then 0 out of 14, and then 4 out of 14 again. Can you go back? For 5 seconds, 10 out of 14 blocks were left standing for 2 of the trials, then 6 out of 14. Well, just more of the blocks were left standing than the 3 seconds. For all 7-second trials, all 14 of the blocks were left standing, so the bridge didn't get destroyed at all. My analysis and conclusion is that a fast flood, which was 1 second, completely wiped out the bridge. A medium fast flood, which was 3 seconds, knocked quite a few blocks over. As a moderate speed flood destroyed only destroyed a few blocks of the model, and a slow flood, which was 7 seconds, did not affect the model. This showed that girder bridges are most vulnerable to fast floods where the water comes all at once. Some future research questions would be, how can girder bridges be reinforced? What are some possible solutions for backup bridges? How do other bridge types stand up to flooding? How can we identify which bridges are at most risk of flood damage based on the surrounding geography? How can we predict future flooding based on data about past events? Are girder bridges being built today strong enough for future weather conditions? And how can we teach communities about the risks of flooding from climate change in the future?
I want you to know that she is 11 years old. Next giving his presentation will be Mr. Casala from Lincoln Middle School.
Good afternoon, ladies and gentlemen. My name is Abid Kasala, and I'm an 8th grade student from Lincoln Middle School. We all know how much plastic pollution there is in the world and how much we use it in our daily lives. So my project is Global Plastic Pollution, the depolymerization of various plastic polymers, and finding the most effective chemical for plastic recycling. To begin with, the abstract. This project is a continuation of my previous year's global plastic pollution project that had the supported hypothesis that plastic takes the longest time to degrade in comparison with other materials like styrofoam, ceramic, and others in soil, water, and salt water. So the two main recycling methods right now are mechanical recycling and chemical recycling. Mechanical recycling is where the plastic is collected, screened, sorted, extruded, and then pelletized. And chemical recycling is where the plastic is sent through the pyrolysis method that converts the plastic into fuel. The problem is that these methods reduce a lot of carbon gases and create additional air pollution. So my experiment is to improve these methods by adding in a stage called immersion before the heating process, where the plastic is immersed in chemical substances to depolymerize the plastics prior to the heating stage. This can help cut down on time, make it a lower carbon footprint, make it more efficient and cost effective. This is my previous year's project board with the data and graphs. So my question is, which chemical substances out of acetone, sulfuric acid, and water as a control, along with bleach, will depolymerize the plastics PETE, HDPE, and LDPE fastest for recycling? My hypothesis was that the lower the pH value of the substance, the higher the rate of depolymerization. The purpose of this project continuation is to perceive the most appropriate liquid chemicals that quickly depolymerize the various plastic polymers quickest for recycling. These images depict the two different processes, the chemical recycling and the plastic recycling. And this diagram shows the different resin ID codes for the plastics. And the ones I chose were 1, 2, and 4, since they were the most commonly used and they vary by the density. These are the materials that I used along with their associated images, such as the chemicals and the plastic samples. So my procedure, I did the experiment in a dedicated room with the proper safety precautions, and the duration was 4 weeks long. So I took 4 sets of these 3 mason jars and filled each with the equal amount of the different chemicals, and I immersed the samples PETE, HDPE, and LDPE in them, and you can see the changes here after 4 weeks to the samples. The acetone sample where the LDPE is in, that one got softer after the 4 weeks. And similarly here for the bleach and the sulfuric acid, the LDPE sample in the bleach got lost all its color and started breaking off into particles. And for the sulfuric acid sample, the PETE got completely dissolved, which supported my hypothesis. And also the LDPE sample lost all its color and started breaking off into particles. And most importantly, the HDPE, it got softer, but I could notice the change in the microscope images that I took. So these are the molecular bonds for the different samples that I used, which were PETE, LDPE, and HDPE, and how they look. So for the physical change, I use these microscope images, and the bottom row shows the sulfuric acid, which you saw in the previous image, and that's the PETE sample, then the second one, and the third one, and that's the one that had the most change in it. Mm, okay. One back. Yeah, I think that's the one. Yeah. So two more back. Okay. So I had tables and charts for it. So basically what they had were the different pH values for the substances along with their weight changes before and after the 4 weeks of the 2 trials that I conducted. So this shows the changes between the 2 trials, and they're identical for the most part, which supports the hypothesis. So hence, sulfuric acid proves to be the fastest plastic depolymerizing chemical to add to a stage called immersion, where the plastic is immersed in the sulfuric acid before the heating stage. And since we're using that because it can depolymerize the plastic rapidly when compared to other chemicals, and it's also reusable. So I showed the other picture. Yeah, so this shows the mechanical recycling process in stages, and by adding my immersion step and washing step in the red boxes, it can help reduce the carbon gases released from the extrusion, which would be really good for the environment. So that's my future proposal by making these more steps, by adding these steps and making them more widespread.
Okay. Our next person is Ms. Gayu, who is from Lincoln Middle.
Hello, my name is Maggie Gao, and I'm a 6th grader at Lincoln Middle School, and my project title is Effect of Fire Extinguisher Foam on Soil Quality and Plant Growth. Fires are a global issue that occur every day, everywhere around the world. Fires can cause several different types of damages, such as economical damage, damage to the environment, and damage to us humans as well. These can occur in a variety of scales, such as a small accident in your backyard, or even a large disastrous wildfire in the wild. Many tools are used to fight fires, but one common tool we all know about and use are fire extinguishers. However, inside of the fire extinguisher foam, it contains a chemical called PFAS. PFAS, or polyfluoroalkyl substances, are a large group of long-lasting man-made chemicals. These are found in many common household products that people commonly use around their house, but however can lead to many toxic and health risks such as cancer and even death. My hypothesis is that due to the toxicity of PFAS, fire extinguisher foam in soil will deteriorate soil quality and reduce seed germination and growth. To test this, I will evaluate the effect of fire extinguisher foam on the germination and growth of green beans in garden soil. This is my experimental setup. I first gathered the same soil from our garden and then sprayed the corresponding amount of fire extinguisher foam into each and separated them into 3 groups, one for control, which would be left alone, one which had fire extinguisher foam sprayed in once, and one which had fire extinguisher foam sprayed in 3 times. Then I separated each group into 5 cups each and planted 3 green bean seeds in each cup. So here are my results. As you can see on day 2, you can tell that there isn't a lot of growth in any of the plants and they all seem the same. While in day 5, you can start to see that the control group plants are sprouting and starting to grow. While in the other 2 groups, which had fire extinguisher foam sprayed inside of them, there's no progress at all. On day 10, you can see that the control plants have grown tall and healthy and green. They're coming out of the cup. While again, in the other 2 groups, there isn't any progress or growth at all. My results. So again, in the control group, you can see that they're all green and healthy and tall and strong. There didn't seem to be any problem with them. While in the other 2 groups, as in T1, which had fire extinguisher foam sprayed in once, you can see that it's a bit white, which is actually that mold that was growing on the seeds, which you could tell that they're definitely not in good condition and probably dead. In the group T2, it looks like dirt because it's burned black. And again, it's probably very obviously dead and burned. So to make sure to watch out from PFAS from common household products such as non-sticking cookware and cleaning products, because again, PFAS is a very toxic group of chemicals that last a long time and can lead to many sicknesses. Thank you for listening to my presentation.
All right, my list. Can you hear me? Our last one is Mr. Sharma. He's from Lincoln Middle School also. He'll present his science project. Go.
Hello, everyone. Good afternoon. My name is Shivin Sharma. I'm an 8th grader at Lincoln Middle School who will be going to Eastside High School as a rising 9th grader. This past year, I competed at the Alachua County Regional Science Fair. So here's my project. So the title of my presentation was the use of stem cells to improve lung regeneration. The base of my project was on the regeneration of artificial human lungs using different kinds of stem cells. In today's world, lung regeneration and accessibility is becoming a very relevant issue, and the lack of it has led to many deaths. Over the past decades of scientific research regarding the regeneration of human lungs and exploration of different methods to improve it, no efficient and clear method has truly been implemented. The goal of my experiment is to take a deeper dive in a statistical approach, comparing and contrasting what works best. I went through multiple published studies and articles to determine the benefits and challenges of using various stem cells in lung regeneration. My ultimate goal is to conduct laboratory research at the University of Florida with scientists engaged in bioengineering artificial human lungs. I'm planning to conduct lab work this summer. So the question for my experiment was, can stem cells help create artificial human lungs? If so, which kind of stem cells are more effective in lung regeneration? My hypothesis was that stem cells can help create artificial human lungs, and pluripotent stem cells are more effective in lung regeneration as compared to mesenchymal stem cells. My approach to this experiment was, in order to do this, I will perform a comparative analysis for the effectiveness of pluripotent or mesenchymal stem cells to regenerate ex vivo lung tissue. So what exactly are stem cells? Well, stem cells are the naive immune cells of the body, which can transform into different kinds of adult tissues and organs. Stem cells have the capability to change into any cell in the body and help support organs that have been damaged in the body. Different types of stem cells exist, that is, induced pluripotent stem cells, also known as iPSCs, and mesenchymal stem cells, MSCs. Regarding lung regeneration, stem cells can regenerate organs as well as repair the damaged tissue. Being the only cell to be able to generate new cells, creating new lungs would be extremely beneficial for society today, which can possibly help impact lung diseases such as COPD, also known as chronic obstructive pulmonary disease, and COVID-19. My experimental strategy for this was that I would have two groups of stem cells that I would test and research on, which were pluripotent and mesenchymal stem cells. So what exactly are these two? Well, induced pluripotent stem cells are stem cells that can be derived from somatic cells and can differentiate into different types of cells. Mesenchymal stem cells, on the other hand, are bone marrow or adipose cells that can self-renew and exhibit multilineage differentiation. After looking through many published studies, I compared information from different stem cells with their impact on lung regeneration. So here we have an example of a human breathing lung on a chip microdevice. The microdevice is used for gaseous exchange once the artificial lung is formed. In brief, it indicates the creation of mechanical breathing movements shown in panels A and B, and physiology of the normal breathing human lung, and assembly of the microdevice for generation of artificial human lungs shown in panels C and D. Our ultimate goal is to create such a microdevice for an artificial lung using scaffold material and stem cells. So the process of artificial lung regeneration involves several steps. First of all, we have to use a scaffold, which can be derived from a native animal or human lung or biomaterial, which undergoes the process of decellularization, which is a treatment with various chemical agents. Secondly, this process involves recellularization factors when we include different cell types, such as alveolar epithelial cells and growth factors. Third, the newly generated lung undergoes implantation. So in this slide shown here is the process of these three steps. First, in decellularization, the lung tissue is stripped of any dead cells, as shown in panel A. The rest of these remaining pictures show histology of lung tissue from decellularization scaffolds. Next, in panel B, shows recellularization, where mesenchymal stem cells are inoculated sheep lung scaffolds to express proteins of extracellular matrix. And lastly, in panel C, the process of implantation is shown. The engineered new lung is surgically implanted into the recipient. In this slide, the schematic diagram shows how AE cells are generated from iPSCs. Immune histology shows staining markers of new epithelial cells such as NKX2.1, EpCAM, and CPM. So these are all important proteins in the production of epithelial cells, and these results show us that iPSCs can robustly generate alveolar epithelial cells. On the other hand, mesenchymal stem cells derived from either bone marrow or adipose cells are weak progenitors of human lung epithelial cells. Shown here is the data from a study where next slide. Oh, correct. All right, that's fine. I'll just. All right, no worries. Yeah, that's fine. That's fine. So on the other hand, MSC derived from either bone marrow, adipose cells, or weak progenitors of human lung epithelial cells. Shown here is the data from a study where 3 different groups were used. AE was normal alveolar epithelial cells, and the second group was AEBM, in which alveolar epithelial cells were treated with bone marrow-derived stem cells. In the third group, we had AEAD, in which alveolar epithelial cells were treated with adipose-derived stem cells. Then the generation of epithelial cells proteins was measured. Only 2 proteins, ICAM1 and MUC1, shown in the red boxes, were increased after either MSC treatment. All right, yeah, okay. In conclusion, my research and data support that stem cells are able to create artificial human lungs, which also supports my hypothesis statement. Also, after analysis, I conclude that pluripotent stem cells are more effective than the mesenchymal ones. Pluripotent cells are very capable of creating artificial human lungs, and further advancement in them will prove to be even more beneficial. I look forward to continue my ongoing summer project at UF. And I had a bibliography of the source I used for my research, but that's all. Thank you very much.
Seems to me we need to give Tom a wonderful hand as well for all that messing around. Well, we don't have time for questions right now, but they'll hang around afterwards and be able to answer questions for you. Hopefully you had a really good time and you didn't learn, and you learned a lot of stuff. Take care. Bye.
Well, that was great. Each of you, wonderful job different projects and different presentation styles. Really, each one of you did so well. Audrey, Maggie, Abith, and Shavin. Shavin, I've got to just say, Cecil and I only know Shavin as somebody that can hit a jumper from the outside. He's played some basketball with us. I didn't realize you were a scientist. Awesome job, each of you. That was really great. And I want to, this is a good time for you all to have kind of an introduction to what Rotary is. This is our Rotary theme this year, Serve to Change Lives. So Rotary is an organization of 1.4 million people around the globe. I think 34,000, I believe, is the latest number of clubs like this one, of people who come together to try to do good in the world. And we're really proud about what our club does here in Gainesville, and we're proud to have a relationship with the Alachua County School Board and be able to support youth. That's one of our 7 Rotary points of focus. So again, each of you, great job. I have a coin that I'd like to give each of you. So come on up here real quick, guys. This is our Serve to Change Lives coin. So how about another round of applause for these wonderful kids. And John, for you, my friend, for all of your work that you do for our club, please come back up here. We've got our coin that this, again, kids, this kind of embodies Rotary also. On the front, it has our Rotary motto, which is service above self. And on the back, it's our Rotary 4-way test, which guides us in our conduct with each other in this room, outside of this room, just all the things we do. We ask, is it the truth? Is it fair to all concerned? Will it build goodwill and better friendships? And will it be beneficial to all concerned? Again, John, thank you. Awesome. This takes a lot of work to get all this. This mic is not. Takes a lot of work to do all this. And Tom, thank you also. Great job, John. Thanks. Okay, and our 50-50 drawing for the Rotary Reading Safari. The last 3 digits are 674. Have a great week, everybody. We'll see you next Tuesday.